All right, guys, I want to go over some of the topics we talked about yesterday during class. I am not really all that concerned at the present moment with you guys writing totally formal proofs for these things. I want you guys to get down the concepts first, and we will worry about the monotony of writing proofs later. I also know it's very difficult for a lot of you guys to physically write a proof, so I'm more concerned that you guys know the components and how to get there, and we will get to the proofs. We will be writing formal proofs. And we'll kind of cross that bridge when we come to it. Right now, I'm really more focused on the concept. So let's take a look at this, okay? So it says quadrilateral ABCD is graphed on a set of axes below. Which quadrilateral best classifies ABCD? Is it a trapezoid, a rectangle, a rhombus, or a square? Well, what do we need to know to classify these things? First of all, we need to talk about whether all the sides are parallel. As we talked about in class, what we're really looking for is the slope. So we want to know, is AB parallel to CD? And we do that by looking at the slope. So what's the slope? Well, the slope of AB, again, I want to 1, 2, 3, 4, 1, 2. So it has a slope of 4 over 2 or just 2. CD or DC has a slope of 1, 2, 3, 4, 1, 2. Well, it's also got a slope of 4 over 2. So far that's true. We can kind of check that off. And that would be something we would write in a formal proof. AB is parallel to CD. Why? They have the same slope. Okay? Let's talk about AD and DC. AD has a slope of 1, 2, 3, 4, 1, 2. So negative 4 over 2 or negative 2. On the other side, BC also 1, 2, 3, 4, 1, 2. Negative 4 over 2 also has a slope of negative 2. Okay? So these are parallel. So far we know we can rule out it is not a trapezoid. What have we said so far? That these sides are parallel and these sides are parallel. Okay. Let's talk about the other things we know. And a rectangle. One of the things you guys know about a rectangle is its diagonals are congruent, right? Very easily, actually, we can say this is 1, 2, 3, 4, right? This is 1, 2, 3, 4. And going down, this is 1, 2, 3, 4, 5, 6, 7, 8. So it's definitely not a rectangle, right? Because this is 4 and this is 8. What you might see, though, is these are perpendicular, which is another thing we know. But that's actually true about rhombuses, and it's true about squares, because squares are rhombuses. So what's the next thing? What would differentiate a rhombus from a square? Pretty much what you're going to look for is, are the sides perpendicular? Now, listen, I know you're looking at this and saying that it's not a square. I know it's not a square, guys, okay? It's clearly a rhombus at this point, but let's just talk about it. Is BC perpendicular to CD? Well, BC has a slope of negative 2 and CD has a slope of positive 2. So no, they are not perpendicular. So therefore we know it is not a square. We know that it is a rhombus. Again, you have to have a negative reciprocal slope. So if it was 2, again, what do we need? We need two things to happen. We need it to be positive, but we also need to flip this fraction. So negative 2 over 1 becomes positive 2. Okay? So again, two things have to happen. Here we just flip the sign. Remember, we have to flip the sign and we need the reciprocal. Okay? All right. Quadrilateral NATS has coordinates negative 4, negative 3, negative 1, 2, 3, 4, negative 1, 2, 3. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 1, 1, 2, 3, negative 1, 2, 3, 4. Okay, and they want you to prove this a rhombus. Now, I will go ahead and be the first one to tell you that this does not look like a rhombus to me. Does it look like a rhombus to you? I don't know. Could be, but not quite as crystal clear, right? So again, let's go ahead and let's label these. We got N A T S. Okay. So again, if we want to prove it's a rhombus, let's go this. We want to say first that NA is parallel to ST, right? First thing. Then we're going to want to go ahead and say is AT parallel to NS. Okay. And then the last thing we want to know is we're going to draw some diagonals. Okay, so I'll put them in there in a second, but we're going to draw some diagonals, and we're also going to want to know, hey, is AS perpendicular to NT? Okay, because that's one of the defining characteristics of a rhombus, right? So is it a rhombus? So we definitely want to know that for sure. Okay. All right. So first, is NA parallel to ST? Well, again, let's count. I got a slope of 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this has a slope of 1, right? 5 over 5 or 1, right? ST, again, if we kind of go corner to corner on the boxes, it looks at 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So far, that checks out. AT, 1, 1, 2, 3, 4, 5, 6, 7. AT has a slope of -1/7, and NS has a slope of 1, 1, 2, 3, 4, 5, 6, 7. Okay, so far it's definitely a parallelogram. Now we want to say, hey, is it a rhombus? What do we know about rhombuses or rhombi? That they have their diagonals are perpendicular. So AS has a slope of 1, 2, 3, 4, 5, 6, 2. So that is a slope of -6 over 2, which again, if we reduce, is going to be -3. NT has a slope of 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's got a slope of +4 over 12, which again, if we have to reduce these things, turns into 1/3. These are indeed reciprocal, negative reciprocals. So if I said, what's the negative reciprocal of -3? Again, I'll throw it over a fraction, so the reciprocal will be 1/3. We switch it from a negative to a positive, and that's us right there. So again, in a proof, this is what we want to be showing. This side is parallel, these sides are parallel, these are perpendicular, and therefore we know it's a rhombus. Are we doing on time? All right, I am going to go past number 8 because it's actually pretty much the same problem. So just want you to prove it's a rhombus. We might have to come back to that, okay? All right, so last one, number 12. Let's go ahead and take a look. It says, has vertices -2, 3, -1, 2, 1, 2, 3, right there. 3, 8, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. This is going to be messed up because graph paper is messed up. 4, 1, 1, 2, 3, 4, 1, and -1, 1, 2, 3, 4. Okay, connect the dots. All right, let's give it a quick little name here. We'll say this is going to be P, Q, R, S. All right, so prove that it's a rhombus. Okay, well, again, same thing. We want to know the same thing. PQ, is PQ parallel to SR? Is PS parallel to QR? Right, and again, what else do we want to know? We want to know, is PR perpendicular to QS? Right, those are going to be the diagonals. Okay, and the last, to show it's not a square, we're going to have to say what? We'll have to say, hey, is SR perpendicular to QR? And what we really want to find out is that these are not. So we want this to be wrong. So this is something we want to be wrong. We want this to be right. right? That'll be a parallelogram. Diagonals are bisect or rhombus. We want this to be wrong. Okay, so let's see, PQ, I got a slope of 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Slope of 1. SR, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so those are good. Those are parallel. PS, 1, 2, 3, 4, 5, 6, 7 over 1. So I'll say slope of -7. Q to R, 1, 2, 3, 4, 5, 6, 7 over 1. Also parallel, right? Same slopes. Are the diagonals perpendicular? They look it, right? So from PR, I'm going down 1, 2, 1, 2, 3, 4, 5, 6. So we're going down 2 over 6, which is also going to be -1/3. Okay, from S to Q, we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, 3, 4. So we want to have 12 over 4, which is 3. So same slopes as last time, very similar to last problem. Okay, -1/3 is, I'm sorry, not equal, and 3. So again, what do? Do we flip the fraction? It became 3 over 1. It was negative, now it becomes positive, and that's us right there. So again, negative reciprocal slope, so that's good for us. So far, so good. Okay, and the last thing which we want to be false is SR perpendicular to QR. Well, SR, we said has a slope of 1. We set that up here. QR has a slope of -7. So no, they are not perpendicular. These are not negative reciprocal slopes, okay? So again, we'll get to the point where we're writing this as a kind of total proof and everything like that. But for now, just, you know, if you guys can kind of follow this logic, if you can explain to me in words, I'm okay with that. We'll worry about the formalities a little bit later, okay? So I don't want to make this too long. We're already at 13 minutes. So you guys go ahead, try 8 by yourself, use 7 as an example. It's almost the exact same problem, okay? So let me know if you guys have questions, and I will talk to you later.